I'd love to see Nathan. If you are unaware of who Nathan Oakley is, let me tell you. We measure Earth flat. So Nathan Oakley is not a very nice person. Talking about the Flat Earth book that he is currently writing. Nathan. And his book is going to be first class. Now you mentioned surveys. And yes, local land surveys use flat approximation for convenience. The best Flat Earth book out there. We'll all await that book with bated breath, and which is Nathan Oakley looking over a flat Earth. This is the end of the Flat Earth debate. Flat Earth win from the elevations are measured from the flat Earth. Okay, look. Land surveyors do often use flat plane approximations over short distances. 6,000 feet above sea level, it means the average level of the ocean. And sea level is assumed to be flat ground forever. Ever heard of that word, Nathan? When you say 6,000 feet above sea level, what you're really saying is sea level is assumed to be flat. 6,000 feet above sea level, since elevations are measured as vertical distances from sea level, measuring a mountain's elevation, it assumes that since elevations are measured as vertical distances from sea level, and sea level is assumed to be flat, then the whole system collapses if Earth is curved. The Earth has curved sea level. Okay, look. Land surveyors do often use flat plane approximations over short distances, and that's why geodetic surveying exists. Every major bridge, or tunnel, or transcontinental railway use flat approximation for convenience. Linear measurements require flatness. Miles only make sense on a flat plane. Rulers only work on flat floors. What Nathan is basically saying here is that by using miles, directions and measurements, you're secretly a flat earther. And yes, local land surveys use flat approximation for convenience, especially over the small distances I mentioned. Especially for locations many miles apart, use flat approximation for convenience. Even manual levelling over long distances and it actually being true are two very different things, Nathan. Trigonometry doesn't care what shape you're on. It's just relationships between angles and lengths. Normal trigonometry gives good approximations. Used by pilots and astronomers and GPS systems. Flat earthers just ignore it. You can absolutely apply trigonometry. In the case of this diagram here, 50 kilometers, so normal trigonometry is absolutely valid. Nathan bangs on about Earth being measured flat. And yes, local land surveys use flat approximation. Now, just to reference the actual video being played here for a second, this is basically the angular size you expect on a flat Earth. The angular size of Pikes Peak from that position is 2.36 degrees. You absolutely do calculate these degrees when talking about how high a mountain appears from a certain location. That's how line of sight works. Elevation angle is often measured by calculating it using height and distance, just like we did earlier. Nathan, and his book is going to be first class, only on a completely flat surface. I'd love to see Nathan.
What you measure it.
The angle to a mountain or a tree depends on height difference and distance, both are which measurable, predictable and calculable. If you claim the Earth to be flat, and you can absolutely test that, Nathan's saying it just is what you measure.
On your knees, acknowledging the linear distance, perpendicular elevation and flat Earth prerequisite elevation angle.
Yeah, okay. On a local scale, I will acknowledge all of that. The Earth is flat. It means you're measuring the shortest path between 2 points. Over small distances, you can use straight line approximations. You measure Earth flat. Dear oh dear, Nathan, this has been an awful video. It really has. Well, there we go. Another one finished all for today. Please do let me know in the comments what you thought of Nathan's performance there. As I say, we measure Earth flat. We're all done and dusted for another one.